definition of circular motion is the movement of an object along the circumference of a circle or along the circular path. And so there's four components to circular motion. First, there is angular displacement expressed in radians. There then is angular velocity, which is expressed as omega and is expressed in radians per second. There's then angular acceleration, which is expressed in this like alpha term, and that's radians per second squared. And then finally, we of course have to take into consideration time. And so this little diagram here shows the velocity in the tangential aspect, acceleration always going towards the center in the direction of motion. And this is what circular motion is.
We are now going to talk about the three equations that are important when it comes to circular motion. The first equation is tangential velocity, which is velocity measured at any point tangent to a turning wheel. This equation is the first one up here, which is the omega cross r. The second equation we're going to talk about is tangential acceleration, which is the measurement of how quickly a tangential velocity changes, which is always perpendicular to centripetal acceleration, which is the third one. And the one that I was just talking about, tangential acceleration, is defined by the change in velocity over change in time, which is alpha cross r. And the last equation would be centripetal acceleration, which is acceleration experienced during uniform circular motion. This is given by omega cross, the product of omega cross r, which equals negative omega squared r.
What's going on, folks? We're going to give you guys a real life example of some circular motion. As you guys can tell, there's a lot on line here. Two crowd members, bowler over here. If she hits this strike, it will be a victory. Here we go.
Oh, Nicolette, you got this.
The body segment we are interested in on this bowler is from her shoulder to her hand. The distance between these 2 points is the r vector, or radius. The centripetal acceleration vector will always be pointing from the end of the segment towards the axis of rotation, which in this case means it points from the bowler's hand to her shoulder. The tangential acceleration and tangential velocity vectors will both be at 90 degrees from the centripetal acceleration. This directional relationship stays the same for the entirety of the throwing motion, and when the ball is released, it will travel in the direction of the tangential velocity vector at the point of release. Its speed can be found by multiplying angular velocity by the radius.
And now, for a second real-world example, let's tune in to Arvin at the UT 2019 Diving Championships.
Coaches holding their breaths.
In this example, the axis of rotation is the center of the diver's mass. We know that every point on the diver's body has the same angular velocity, but different points have different tangential velocities. We know based off of the equation for tangential velocity that the larger the radius, the faster the velocity. Therefore, when the diver is in his tucked position, his head and feet will have a higher tangential velocity than his torso.
And it's a good one.
A very good dive.